Welcome to Lesson 14. In this lesson, you will determine if a phase change is endothermic or exothermic. You will interpret a heating or cooling curve, and you'll differentiate between potential and kinetic energy changes in a phase change diagram.
Make sure you follow along and examine this diagram found on your guided notes handsheet as you complete this table. This area of the table we will not discuss in this video, as it will be part of a future lesson. A phase change diagram shows the changes as heat is added or removed from a sample at a constant rate. Like if you put a pot of water on the stove and you turned it on to medium and didn't increase or decrease its heat. These are often called time temperature graphs. Temperature, or average kinetic energy, is always the y, and time, or reaction progress, is always the x. Here you can see that we have outlined the three major states of matter and the phase changes that occur between them. The first slant of our graph here, we have a solid that is warming up. It must warm up to its melting point before it can change state. When solid is warming, its temperature is increasing, but its potential energy, or the position between the particles, is the same. Solid particles are in fixed geometric crystal lattice structures. The position of their particles does not change until it reaches its melting point. So the potential energy is constant. Now here, in section B, we have reached the melting point. Here, the temperature is actually constant. Imagine if you had ice and water. As the ice is melting, the water cannot get any warmer until all the ice has melted. So here, the temperature is constant, but our potential energy is increasing as more and more of the particles are changing from the solid phase to the liquid phase. The liquid phase, the particles are more spread out, so they have a higher potential energy. The amount of heat required to melt a solid substance into a liquid substance is called the heat of fusion. In chemistry, melting can also be called fusion. In section C, we have a liquid that is warming to its boiling point. Here, the liquid has a constant potential energy, as the particles are still close together, but moving past one another. Our kinetic energy, or temperature, is increasing. Here we have yet another plateau. We can notice on phase change diagrams, plateaus are synonymous with phase changes and potential energy changes. PPP. Plateau, phase change, potential energy change. In section D, the phase change is boiling or evaporating. We are changing from a liquid to steam. The steam, or water vapor, cannot get any hotter until all the liquid is first converted into steam. Finally, we arrive at the gaseous state. Here, the steam is getting even warmer. Notice, for all parts of this graph, only one type of energy changes at a time. Either the potential energy changes at the plateaus, or the kinetic energy changes on the slanted portions of the graph. Can you identify the melting point of this substance from its phase change diagram? Here is another phase change diagram, but notice as time goes on, our temperature of our substance is decreasing. This is called a cooling curve. We begin our cooling curve in the gaseous state. We'll move where the kinetic energy, or the temperature, decreases as the potential energy remains constant. When we move to the plateau, number 2, what we'll have is a potential energy change. But since this graph is decreasing, our potential energy will also be decreasing. So here, our potential energy decreases as our kinetic energy is constant. This is when the gaseous state turns into a liquid. The liquid cannot begin to cool until all the vapor has been converted to liquid. In section 3, we have only the liquid state. Here, our kinetic energy is decreasing, and our potential energy is constant. In section 4, we have a plateau. A plateau is a phase change and potential energy change. Here, our potential energy will decrease as we change from the liquid to the solid state. On this plateau, we have both states of matter. Finally, in section 5, we have a decrease in kinetic energy and constant potential energy as our solid is cooling. Try your hand at a few Regents practice questions related to reading heating curves and cooling curves.